Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable coefficients. So let's get going. Problem: solve x square d square minus xd plus 4 into y equals to cos of log x plus x sine of log x. So here we are given a differential equation with variable coefficients. Now we are going to reduce this given equation to a differential equation with constant coefficient by making substitution. Okay, and also we are given Cauchy's equation. Given Cauchy's equation, x square d square minus xd plus 4 into y equal to cos of log x plus x sine of log x. Now let's make the substitution. Put x equals to e power z, then log x to the base e equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Okay, then x is theta. X square d square is theta of theta minus 1. Now this equation becomes, replace x square d square by theta of theta minus 1, we'll get theta of theta minus 1 minus replace xd by theta plus 4 into y equal to cos of, replace log x by z, will get cos z plus x, replace x by e power z into sine of, replace log x by z, right? Then theta into theta, theta square minus theta into 1 theta minus theta plus 4 into y equal to cos z plus e power z sine z, right? This becomes theta square minus theta is minus 2 theta plus 4 into y equal to cos z plus e power z sine z. So we have reduced the given differential equation with variable coefficients to a differential equation with constant coefficients, and also this is in operator form, f of theta into y equals to some function of z. So this equation, theta square minus 2 theta plus 4 into y equals to cos z plus e power z sine z, which is in operator form. F of theta into y equals to some function of z, where f of theta is theta square minus 2 theta plus 4. Now we are going to solve, we are going to find the general solution of the given equation, which is given by y equals to yc plus yp, right? First we will find yc and later we'll go for yp. So we'll find yc using the auxiliary equation. The auxiliary equation is f of m equals to 0, where f of m equal to, we have f of theta, theta square minus 2 theta plus 4, right? Let's replace differential operator theta by m, so that we'll get f of m equals to m square minus 2m plus 4. Now the auxiliary equation becomes m square minus 2m plus 4 equals to 0. Now we know we need to find roots of this equation. We'll find roots using quadratic formula, m equal to minus b plus or minus square root of b square minus 4ac by 2a, right? Now just compare this equation with quadratic equation in m. We'll get a equals to 1, b equal to minus 2, c equals to 4, right? Now substitute these values in the formula. We'll get minus of minus 2 plus or minus square root of b square minus 2 whole square minus 4 into a 1 into c 4 by 2a, 2 into 1, right? Then this becomes m equal to minus of minus 2 is 2 plus or minus square root of minus 2 whole square is 4 minus 4 fours are 16 by 2. Right? This equals to 2 plus or minus square root of 4 minus 16 is minus 12 by 2. This equals to 2 plus or minus square root of, we can write minus 12 as minus 1 into 12. And again we can write 12 as 4 into 3. Right? Now split square root of minus 1 into square root of, square root of minus 1 into 4 into 3 as square root of minus 1 into square root of 4 into square root of 3 by 2, which is equals to 2 plus or minus, we know that square root of minus 1 is I and square root of 4 is 2. Then this becomes 2 plus or minus I into 2 into square root of 3 by 2. Now take 2 common from the numerator, we'll get 2 times 1 plus or minus I root 3 by 2. So 2 gets cancelled and we'll get 1 plus or minus I root 3. Okay, so we got pair of complex conjugate roots of our auxiliary equation. Now let's write the complementary function. Therefore, m equals to 1 plus or minus I root 3 is a pair of complex conjugate roots. We know that a plus ib is a complex number, then its conjugate is a minus ib. Likewise, a minus ib is a complex number and its conjugate is a plus ib, right? Then we can call a plus or minus ib as a pair of complex conjugate. If m equals to a plus or minus ib, then we call it as a pair of complex conjugate roots, right? When m equals to a plus or minus ib, then yc looks like e power az into c1 cos bz plus c2 sin bz. Now just compare our roots with a plus or minus ib. Then for a equals to 1 and b equal to root 3, we'll get complementary function yc equals to e power, for a equals to 1, we'll get 1 into z into c1 cos bz plus c2 sin bz. This is equals to e power z into c1 cos root 3z plus c2 sin root 3z. Now we are having yc in terms of z, but we need to write in terms of x. So what we'll do, we'll just replace e power z by x and z by log x. Okay, then yc becomes x into c1 cos root 3 log x plus c2 sin root 3 log x. Okay, so we got yc. Let's now find yp, particular integral. Now coming to particular integral. We'll find particular integral using 1 by f of theta into q of z. This equals to, we have f of theta and q of z, right? Where f of theta is theta square minus 2 theta plus 4 and q of z is cos z plus e power z sin z. Also we can write this as 1 by theta square minus 2 theta plus 4 into cos z plus 1 by theta square minus 2 theta plus 4 into e power z sin z. Let's now find each term separately for our convenience, okay? First one, 1 by f of theta, theta square minus 2 theta plus 4 into cos z. Right. This is of 1 by f of theta into cos az form, right? For equal to 1. we'll find theta square, which is given by minus of a square, which is equals to minus of 1 square, which is minus 1, right? Now, we need to check the denominator by replacing theta by minus 1. Always remember that the denominator must be non-zero. If the denominator becomes 0 after replacing theta square by minus 1, we'll get something like this, 1 by 0 into cos z. Since 1 by 0 is undetermined or undefined, so the total term becomes undefined, right? So always remember that the denominator must be non-zero. So I'm going to check the denominator by replacing theta square. Just replace theta square by minus 1, we'll get minus 1 minus 2 theta plus 4 is equals to minus 1 plus 4 is 3 minus 2 theta, which is non-zero. So we can dare to replace theta square by minus 1 in the denominator. Replace theta square by minus 1, then this becomes 1 by minus 1 minus 2 theta plus 4 into cos z. This equals to 1 by minus 1 plus 4 is 3 minus 2 theta into cos z, right? Now, if you notice in the denominator we are having 3 minus 2 theta. Just replace this minus with plus, then we'll get 3 plus 2 theta, right? Now, multiply and divide 3 plus 2 theta to this fraction. This becomes 1 into 3 plus 2 theta is 3 plus 2 theta by 3 minus 2 theta into 3 plus 2 theta is 3 plus 2 theta into 3 minus 2 theta, right, into cos z. So this is of a plus b into a minus b form, so we can write it as a square into b square. Okay, sorry, a square minus b square. Then this becomes 3 plus 2 theta by 3 square. We can write the denominator in terms of a square minus b square, right? Minus 2 theta whole square into cos z. This equals to 3 plus 2 theta by 3 square is 9 minus 2 theta whole square. 2 square is 4 and theta square. Right? 2 square is 4 into theta square. You'll get 4 theta square. This is equals to 3 plus 2 theta by, right. Now, again, theta square appears in the denominator. So what we have to do? We have to replace theta square by minus 1. And while replacing, we have to remember that the denominator must be non-zero. Okay, we'll just check it out by replacing theta square by minus 1. We'll get 9 plus 4, right? 9 minus into minus plus 4 into 1, 4, which is equals to 13, non-zero, right? So let's replace theta square by minus 1 in the denominator. We'll get 9 minus 4 times minus 1 into cos z. This becomes 3 plus 2 theta into 9 minus 4 into minus 1 is plus 4 into cos z, which is equals to 3 plus 2 theta by 13 cos z. Again, we can write it as 1 by 13 into 3 plus 2 theta into cos z, which is equals to 1 by 13 into 3 cos z plus 2 theta cos z. This becomes 1 by 13 into 3 cos z plus 2 into, here theta is a differential operator, right? We can just replace theta by d by dz. In the next step, we'll find derivative of cos z with respect to z. Okay? Is equals to 1 by 13 into 3 cos z plus 2 into derivative of cos z with respect to z is minus sin z. Now this becomes 1 by 13 into 3 cos z plus into minus minus 2 sine z. So this is the result obtained from the first term. Now let's go for the second one. Second one, 1 by f of theta into e power z sine z. This is of 1 by f of theta into e power az into sine bz form. Okay. So we'll shift e power az towards left by replacing theta. This is of e power az into v. Okay. For v equals to sine bz, we'll do it later. Just replace theta by theta plus a. And later we'll operate v with 1 by f of theta plus a. Okay. Now compare e power z with e power az. Then for a equals to 1, we'll find theta plus a, which is equals to theta plus 1. Now shift e power z towards left by replacing this theta by theta plus 1. We'll get theta plus 1 whole square minus 2 times theta plus 1 plus 4 into sine z. Is equals to e power z into 1 by theta plus 1 whole square is theta square plus 1 plus 2 theta minus 2 theta minus into plus minus 2 into 1 2 plus 4 into sine z. Now in the denominator plus 2 theta minus 2 theta gets cancelled. We'll get e power z into 1 by theta square plus 1 plus 5, sorry, plus 4 is plus 5 minus 2 is plus 3. We'll get theta square plus 3 into sine z, right? See, this is of 1 by some function of theta into sine z form. Okay, sine bz we can say. Now, we'll find theta square by minus of b square, which is given by minus of b square, right? Just compare sine z with sine bz, then for b equals to 1, we'll get theta square equals to minus of 1 square equals to minus 1. Okay. By replacing theta square by minus 1 in the denominator, we'll get the denominator which is non-zero. Okay. Always remember that the denominator must be non-zero. If you want, I'll show this for you. Just replace theta square by minus 1. We'll get minus 1 plus 3 is 2, which is non-zero. Right? We got non-zero number in the denominator or non-zero term in the denominator. So let's replace theta square by minus 1 in the denominator. This becomes e power z into 1 by, just replace theta square by minus 1, we'll get minus 1 plus 3 into sine z, which is equals to e power z into 1 by minus 1 plus 3 is 2 sine z, which is equals to 1 by 2 into e power z sine z. So this is the result obtained from the second term. Now coming to yp. Yp becomes, result obtained from the first term is 1 by 13 into 3 cos z minus 2 sine z plus result obtained from the second term is 1 by 2 e power z sine z. We are having yp in terms of z, right? But we need to write in terms of x. So we'll just replace e power z by x and z by log x, then yp becomes 1 by 13 into 3 cos of log x minus 2 sine of log x plus 1 by 2 into replace e power z by x, we'll get x into sine of log x, right? Or we can write it as 1 by 13 into 3 cos of log x minus 2 sine of log x plus 1 by 2 into x can be written as x by 2 into sine of log x. So we got yp and yc. Let's now write the general solution. The general solution is given by y equal to yc plus yp. Then y equal to yc we have x times c1 cos of root 3 log x plus c2 sine of log x. Okay, we'll have root 3 log x. Okay. Plus yp 1 by 13 into 3 cos of log x minus 2 sine of log x plus x by 2 into sine of log x. So this completes the problem. So we have seen a problem from higher order linear differential equation with variable questions in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.